Pinacole Pinacolone rearrangement. In Pinacole Pinacolone rearrangement, the 1,2-diol compound, 1,2-diol type compound in presence of 30% H2SO4 will be converted into ketone type compound. Suppose if I take example of tetramethyl 1,2-diol, this is a 1,2-diol and tetramethyl group. So these are four methyl groups, tetramethyl 1,2-diol. Now in presence of 30% H2SO4, this will be converted into ketone type compound after the rearrangement. Here we will see the detailed mechanism how this compound is formed. So in mechanism part, let us start with first step, that is attack of proton. Why proton? Because here our reagent is H2SO4, which is a acid. So this tetramethyl diol in presence of H2SO4, there will be attack onto the OH group. Now we know that oxygen has a lone pair of electron. This lone pair of oxygen will make a attack onto the H plus, and there will be formation of hydronium ion CH3 CH3. Now this OH as it is, now CH3 and OH. Now as the oxygen attack of lone pair from oxygen is made towards the hydrogen atom, this oxygen will be electron deficient. Here both OH are equivalent. These both OH are equivalent, so we can attack on any of the OH group. Now there will be elimination of water molecule. So these bond pair electrons are attracted towards the positively charged oxygen. There will be removal of water molecule. This acid 30% H2SO4 also act as a dehydrating agent. So here water molecule is removed and there is a formation of positive charge onto the carbon atom from where the water molecule has eliminated. So we can say there is a formation of carbocation. The intermediate here is a carbocation. Now rearrangement will take place if there is a formation of more stable carbocation. So this carbocation, it is a tertiary carbocation. Now if this methyl group, any of the two methyl group migrates towards the carbon atom, then also there is a formation of carbocation, but now the positive charge will be shifted to adjacent carbon atom after the migration of methyl. So we can rewrite this structure as CH3C. Now as this methyl has migrated to the positively charged carbon atom, by taking the electron pair, this carbon will be electron deficient and there will be positive charge on that carbon atom. So we can rewrite this structure as CH3 and one CH3 which has migrated. Now this is carbocation, but this carbocation is stabilized by resonance. This carbocation is stabilized by resonance. We can say this positive charge carbon containing carbon atom is attached to OH group. So this is more stable, secondary carbocation. Here also we can see that after this removal of H, we can form C double bond O. So this step is minus H plus. So bond pair of OH is been transferred toward the CO bond. So there will be formation of C double bond O, CH3, CH3, CH3. This is the formation of pinacolone. So we discuss some other example where two OH groups are not equivalent. Suppose I am taking phenyl group on one carbon atom while methyl group on another carbon atom. Now what will be the possibility of formation of carbocation and the migration? So as discussed in the earlier example, first step will be protonation. So now we can, here two OH are, instead of CH3 we have to consider, instead of CH3 we have to consider here pH, phenyl. In earlier example it was CH3. Now these two OH groups are different, so we don't know where the attack will take place. So let us consider example on both the OH. So by this, if I am attacking on the OH which has a phenyl ring, I am labeling it as a root A and this one as root B. So from root A and root B, in the first step there will be the protonation. So lone pair of oxygen will attack onto the OH. From similarly in root B also lone pair can attack onto the H plus and there will be formation of hydronium ion OH2 plus, OH2 plus. Now pH, pH, CH3 and CH3. In the root B, what we are doing, we are attacking to the OH which has a methyl group, the carbon that has a methyl group CH3. Now this OH is as it is, pH and pH. Now the next step is the elimination of water molecule minus H2O in both the sides. So here H2O is removed, here also H2O is removed. So here after the removal of H2O, the carbon atom will be electron deficient. Now this carbon atom has a pH ring. Positively charged carbocation has pH ring adjacent to it, CH3OH. While on the root B, the positively charged carbon atom will have CH3 adjacent to it, CH3 adjacent to it. Now there are two carbocations, suppose carbocation A and carbocation B. Looking at the structure, we can say that carbocation A is more stable. Why? Because it is resonance stabilized by the phenyl. If we discuss the phenyl ring, then phenyl ring has the resonating, phenyl ring can form resonating structure. This positively charged can be migrated across the ring. So as the resonating structure increases, stability will increase. So carbocation A will be formed while B will not be formed. So now further reaction, what will happen? There will be formation of carbocation A. Now this carbocation is less stable as compared to the carbocation that will be formed in the next step after migration of the methyl group. So methyl will migrate in the next step with it. We can say it is a 1,2 methyl migration, 1,2 methyl migration. I am writing here minus because it will take electron pair with it. So the next structure will be CH3 C CH3 OH and here will be positive charge. Now this positive charge will be neutralized by the bond pair of electron from OH bond and there will be corresponding formation of ketone derivatives PH CH3. Now there will be C double bond O CH3. Let us discuss one more example. Suppose I have the following structure. Now where the attack will take place, COH COH. This is our 1,2 diol. Now here there is one phenyl group. This carbon also has one phenyl group. Now let us discuss another group at both the carbon atom which are different. Now suppose this, on this phenyl ring there is a NO2 group which is a electron withdrawing group, while on this carbon there is a OCH3 group which is a electron releasing group. So what will happen after the attack of H plus? Suppose I don't know where attack is taking place, then I can rewrite both the structure. Now suppose this OH is making attack, I am labeling it as a path A. If this OH is making attack, I am labeling it as a route B. So I am directly writing the structure after elimination of the water molecule. So first step there will be formation of hydronium ion and after the removal of water molecule there will be formation of positively charged. In route A, positive charge will be with the carbon atom that has phenyl ring with electron releasing group, while the remaining structure remains the same. So I am rewriting it as the same structure here, NO2 group. Now on the path B, after the removal of hydronium ion, The positive charge lies with the carbon which has phenyl ring with electron withdrawing group. Other structure, remaining structure will remain the same. Now, which carbocation is more stable? A, the carbocation that is formed by root A or root B. So here I am labeling this carbocation as A and this one as B. Now, as the charge decrease, stability will increase. We know that as the charge decrease, it means that stability of intermediate will increase. So here there is a positive charge. Positive charge will decrease when there is an electron releasing group. So this electron releasing group will have an inductive effect on the neighboring carbon and it will neutralize the positive charge. While in carbocation B, NO2 is an electron withdrawing group. So it will try to withdraw electron from the adjacent carbon atom. Here charge will increase. In this case, charge will increase. In this carbocation, charge will decrease. So stability of A is more as compared to B, and therefore A will be formed and not the B. So in the next step, what will happen? There will be migration of. Now migration, there are two groups present for migration. Whether I have to migrate pH or I have to migrate NO2. So the group which will stabilize the positive charge will try to migrate. Here NO2 is electron withdrawing group. So it, it will not decrease the charge very much as compared to phenyl ring. So in this case, phenyl ring will migrate. So phenyl ring will migrate towards the positively charged carbon atom. The remaining structure I am rewriting the same. Here there will be OCH3 group. Now after the migration of pH, there will be positive charge OH. I am rewriting as a different atom. Now there will be NO2 group. With the elimination of H plus minus H plus in the last step, deprotonation, there will be formation of C double bond O pH with the NO2 group, while this carbon atom will have pH and remaining benzene ring with OCH3 group. So in Pinacole Pinacolone, we have to know the sequence of migrating group. So migratory aptitude for different groups are hydride ion will migrate first. After that, stability will increase of the carbocation if phenyl ring will have electron releasing group. Then after phenyl ring with electron withdrawing group. After that, we can say there will be migratory aptitude that is favorable for alkyl in the sequence 3 degree greater than 2 degree greater than 1 degree. Why this is the sequence? Because our intermediate is carbocation and carbocation will be easily stabilized. It will be easily stabilized by phenyl with electron releasing group. So phenyl with electron releasing group will have a higher migratory aptitude as compared to phenyl with electron withdrawing group. Then after there is a order of 3 degree, 2 degree and 1 degree alcohol. Sorry, 1 degree alkyl.